You know that feeling when you click on a live stream, like from a remote mountaintop or a massive protest, and you just brace yourself?
Oh yeah, the dreaded buffering wheel.
Right. The video freezes, the audio drops out, and you're just left staring at a spinning circle.
It's frustrating, but we've all sort of been conditioned to just accept it. I mean, the assumption is that if you're out in the field, away from a stable fiber connection, you are going to lose your signal.
Exactly.
Yeah.
But the wild thing is that professional broadcasters actually aren't dealing with that anymore. So, welcome to your custom-tailored deep dive.
Glad to be here to unpack this.
Yeah, if you're wondering why we're spending time today on the technical specs of a piece of commercial broadcast hardware, it's because this single device is a masterclass in beating that buffering wheel.
You're talking about the Kiloview KVW-P3 5G bonding video encoder from HDTVSupply.
That's the one. It basically guarantees flawless live video from the most, unpredictable remote scenarios on Earth.
It really is a fascinating piece of engineering because to understand how it pulls this off, you have to look at its two distinct superpowers. First, how it compresses the video, and second, how it actually routes that video to the internet.
Right. So let's start with the compression. The P3 can pull an incredibly high-quality video, like 4K resolution at 30 Hz through its HDMI input, or 1080p at 60 Hz via its 3G SDI input.
Which, just to translate the broadcast jargon there for you, hertz just means frames per second.
Right, right. And 3G SDI is that heavy-duty lock and cable connection professionals use. So like a camera operator doesn't accidentally kick the plug out midstream.
Exactly, but that is a massive amount of visual data. Sending raw 4K video over a cellular network is basically impossible.
Yeah, which is why the P3 relies on H265 or HEVC encoding. I always think of this like using one of those vacuum-sealed travel bags.
Oh, that's a great analogy.
Right. It takes your massive video file, sucks all the empty air out, and crams it into half the digital space of the older H264 standard. So you save over 50% of your bandwidth right off the bat.
The vacuum bag is a great way to visualize the size reduction, but the actual mechanism of how H265 works is, well, it's much smarter than just squishing data together.
Wait, really? How so?
Instead of taking a picture of every single pixel 60 times a second, H265 acts like a motion predictor. So, say a reporter is standing in front of a brick wall. The encoder says, okay, the wall isn't moving.
Oh, I see.
Yeah, it only transmits the data for the brick wall once, and then it strictly updates the data for the reporter's moving lips and body. By only sending what actually changes frame to frame, it slashes the data load in half.
Oh, wow, that makes total sense. It's not just shrinking the file, it's eliminating the redundancy.
Exactly.
But, okay, here is where my brain gets stuck. Because vacuum packing your data and predicting motion is brilliant, but it won't save you if you're, like, at a crowded music festival and the local cell tower gets completely overwhelmed.
Right. If the network drops, your highly efficient data still has nowhere to go.
Exactly. So how does it handle that?
Well, that brings us to the device's second superpower, which is Kilo-Link multi-connection bonding. Out of the box, the P3 connects to 6 different networks at the exact same time.
6 all at once.
Yeah. We're talking 4 different 5G cellular networks plus Wi-Fi and Ethernet.
Okay, wait, let me pause you there. When you say bonding, how is it actually using those 6 networks? Is it just picking the strongest 5G signal, and then if that tower crashes, it switches over to the Wi-Fi?
No. What you're describing is a standard failover. Bonding is much more aggressive. The P3 literally chops your live video up into thousands of tiny digital packets.
Okay.
And it fires them simultaneously across all the available networks. So packet A goes over the AT&T 5G, packet B over Verizon, packet C over the Wi-Fi.
Oh, I get it. It's like breaking up a massive delivery into a fleet of different trucks and sending them down 6 different highways at once.
Yes. Perfect way to put it. And on the receiving end, a server catches all these packets and stitches them back together in milliseconds.
So if one highway gets shut down by a traffic jam, the other trucks are still leaving. The package still gets there.
Exactly.
But what if I'm broadcasting from a rural area and there isn't a single 5G tower for miles? Are those 4 5G modem slots just useless plastic at that point?
That is where the modular design comes in. Those motors easily snap out. So if you're in a 4G only area, you just swap in 4G modems.
Okay.
Or you can slot in additional Wi-Fi modems. You can actually scale this device up to bond 10 different IP connections at once.
10? That is wild.
And it gets better. It can even work in reverse, acting as a Wi-Fi hotspot.
Wait, really?
Yeah, so your crew can transfer laptop files over whatever local network the P3 manages to stitch together.
That level of flexibility is just amazing. Commercially speaking, the P3 retails for $1,599. Although if you grab it from HDTVSupply, you can use the code 10% off at checkout.
And you really can't argue with their track record. I mean, HDTV Supply has over 10,000 positive reviews online.
I saw those.
Yeah, my personal favorite is a hilariously honest 5-star review from a guy named John M. He gave them a perfect rating, but his only comment was, "When I called, the staff was less than friendly but answered my question."
Hey, 5 stars is 5 stars. They got the job done, no fluff needed.
Just like the hardware itself.
Exactly.
Yeah.
And honestly, looking at hardware like this forces you to rethink everything. We used to need a $1 million satellite truck parked outside a venue to do what this one little backpack-sized device does right now.
It completely democratizes broadcast.
It really does. It makes you wonder, when anyone, anywhere, can strap on a device and become a glitch-free walking TV studio, what does the future of live, decentralized journalism actually look like?
It's a huge shift.
Right. The
Yeah.
bottleneck used to be getting the signal out to the world. Now that the bottleneck is completely gone, what are we going to do with that power?